I was just having a chat a few minutes ago with today's guest on the GreenTech Pulse podcast, and she told me something interesting that makes a lot of things about batteries make sense, which is that the cathode, which is the positive part of the battery, costs makes up 60% of the cost of a battery. And what she does, what they do at Sylvatex is finding better ways to manufacture these cathodes to reduce the cost of batteries, which obviously would make everything that uses batteries cheaper. So our guest today is Virginia Klausmeier. She's from Sylvatex, and we'll be talking cathode. We're talking about chemistry. I last did chemistry like 14 years ago, so I'm very rusty, but I know most of you listening didn't do chemistry, so we'll talk about it on a very simple level. So welcome to the show, Virginia.
Thank you so much. Thank you so much for having me.
Thank you so much for coming on. So now, we are talking about these cathodes earlier. So can you just break it down for us why they are important, why what you do is important, and how it affects the green tech space generally?
Completely. I mean, just to start at the beginning, I think many of us probably agree we're at the beginning portion of the largest energy transition that's going to happen for our lifetime, which is really exciting. And at the foundation of that energy transition, really powering or storing the power, et cetera, are batteries. So you have not only the energy storage, which allows for unlocking, solar and wind, et cetera. But also you have electrification of vehicles and transportation that is, a large portion of the global greenhouse gas emissions. And what you over time, the battery packs have gotten such, much lower in the last decade to make EVs, electric vehicles, actually be viable. And now you're starting to see them get even lower in cost. So energy storage is becoming much more prevalent. But the thing that's interesting is that majority of the batteries have been concentrated in production in primarily China. And you have materials being mined all over the world and then being refined in China or within the Asian region and then formed into the battery packs. And then those are shipped all over. The long story short is when you look at the carbon life cycle of a battery pack and the cost of the battery pack, it doesn't make sense to have the supply chains be so dispersed, like so concentrated, I guess, in one area when you're collecting all these components. So sort of zooming back out, big energy transition, the volumes of material that are going to be needed to power this future is astronomical. And as it comes, as a not only like globe, but each country and each region is going to have to get smart on forming parts of being participating in that energy supply chain, not only from manufacturing, but also producing to even get the volumes that are needed for unlocking the clean energy revolution. So it's, I would say battery and battery materials, huge trillions of dollars to be made across the supply chain. And there's also a big opportunity and need to do it better because we can't create a new, another carbon problem while
Yeah.
we're trying to solve for one in a different way. Right. So it's, you have the carbon problem and then you just have the global political element of, that drives energy security and global economics, which is really, these are major drivers for the industry.
Interesting. So now, you talked about doing it better and reducing this carbon footprint and everything from the weird supply chain we have for batteries
Mhm.
currently. So, what does your company do? How does your company do this better? What's innovation here?
Yeah. So when we really looked at, I mean, we came from the problem solution set and said, okay, we know that industrial manufacturing energy accounts for like 70% of the global emissions, right? So making materials and the energy sector are both very energy intensive and usually done poorly. And then you have the other side of the coin where if you want to unlock the energy transition, batteries need to get cheaper and be made better. Where we focused our attention was how to look at better ways to do industrial manufacturing for making the most important battery components, right? So the thought was, well, if you look at the battery pack and you have the plus side of the battery, the cathode, you have the anode, and then the electrolyte, and a few other components. The cathode makes up 50 to 60% of the cost of the battery. So, and if you also look at the carbon footprint of the battery, it also makes up about 50 to 60% of the carbon footprint of the battery too. So what that tells you is it's expensive and it's not made very efficiently, right? So there's a lot of room for opportunity for optimization. So we really focused our approach there, and we looked at what was currently being done to make most of the cathode materials. And the sort of general sense was it's not simple and not flexible enough of a manufacturing technique to be scalable outside of many different regions, right? You need more flexibility. I mean, when you're making big volumes of material, you need to have more flexibility on feedstocks. If it's coming from recycled materials or other materials, you just have to have more flexibility in the system, and the current process doesn't allow for that. And it also has it's very energy intensive and has a lot of waste. So a lot of water waste, a lot of water utilization, a lot of sodium sulfate waste, which is a big problem. And these are all factors that are making it more expensive, right? But it's also very energy intensive and environmentally intensive. So where we focused was, we said, okay, if we were making, we don't want to make new materials. So we want to make the materials that the car OEMs and all of the battery users want to make today, like the LFP that's in your battery, right? We want to be able to make that LFP. We want to be able to make the NMC that's used in sort of high performance vehicles, but we want to do it in a way that uses no water, allows for much more flexibility in the system on feedstocks and on output. So if you imagine a process, instead of having a $1 billion asset that can only make one end material and has a lot of waste, you can spend $500 million and get an asset where you can use lower cost feedstocks. You have no waste. It's a single step, and it can switch between different chemistries, or has the flexibility to expand from there.
Interesting. So you said something interesting, that the process you use uses no water. So yes. So can you just for those of us who didn't know chemistry and those of us who have forgotten our chemistry too,
Yeah.
yeah, explain what that means. What does the current how does the current process with water work? How does your process work differently?
Yeah, and I mean so I'm going to I'll probably do a really bad example, but in general, how it's done today is, if you imagine all these metal like nanoparticles, right? A little nickel with lithium, and they're trying to come together at a nanoscale. How it's done today is the first step of it is you mix it into water, so then the nickel and the cobalt and the manganese can come together, and then it co-precipitates out. So there's huge amounts of water used in that process. A lot of waste comes off of it. And then you grind up the lithium to have it come together in the molecule. And then you sort of calcine it. So you put it under high heat to form the crystal. What we did was we said, that doesn't seem like the most effective way to bring the materials together. And then you also have this interesting concept where if you're recycling materials, you're taking these components you spent a lot of energy to put together, and you're separating them all, which is hard to do. And then you're bringing them all back together, right? So our process is a single step, meaning all the components go in one pot at first. which means that you can have recycled materials. It also means that when you're mining nickel, for example, and you have contaminants like cobalt and manganese, you can use those directly in um, as a feedstock. So you have a broader range of feedstocks that are less processed, which is great. And then we use an organic, but that just is a fancy way of saying like an additive that allows for most of the components to come together more efficiently. So if you kind of imagine, if you're baking a cake and you're putting all the components and you need a little bit of something that makes something liquid, you can use a binder, like some portion of an egg or something like that to have it come
Yeah.
together. But then, when it goes into the step where you do calcine it, which is just putting it under high heat, that burns off. So it acts more like a catalyst to catalyze the reaction, but then it burns off. We use very small amounts of that, but it aids in the reaction. So it allows us not to have to do these high energy intensive multi steps, but being able to do it in a single step. And it's just pretty much smart process chemistry with using the concept of like kind of biomimicry in industrial manufacturing.
Interesting. So I think, from what I understand, the current process uses water, mixes up all the components, and later tries to separate the water from the components. But what you do is you mix all the components in a single step with a catalyst, and that sorts everything out. I hope I'm right.
Yeah, I mean, and it simply said correct. Yeah. So that's
Okay,
yeah.
so now looking at that, how much? Okay, let's look at it from two ways: the environmental and the cost impact. How much cheaper is it to manufacture a cathode using your process, and what environmental impact does it have?
Yeah, good question. So the first part of it is when you look at the cost component, and I'm going to use the chemistry NMC because it depends on each chemistry on the different cost components. But NMC is a good example that's used very predominantly as one of the most primary chemistries. We can reduce the cost per unit economics somewhere between 20 to 25%. So
Oh,
that's pretty substantial. What that means for, just to kind of give you a sense of what that means for like a end OEM is, if like a Tesla used our process to make the NMC and just, their Cybertrucks, um, last year, it would have saved them $1 billion,
wow,
which would have
wow,
been, so it's about $1,000 per vehicle, about $1 billion, which is about 10% increased profit margin, which is just, so it's substantial. So that's without really changing design of a vehicle or chemistry of the batteries or any of the things, right? Um, so that there's a lot of money on the table when you're starting to add up these benefits. And in energy storage, it's even more substantial because it's such high volumes there. Um, and then the energy intensity like of the process itself goes down like 80%, so it's substantially less energy intensive. And then the thing that's interesting when we've done the full techno-economic assessments, and generally in the space there's not good documentation of water waste and other sodium sulfate waste and sort of the cost and environmental effects of that. So the industry has definitely some work to get better at the implications, because those are actually one of the rate limiting steps for building outside of China. The wastewater that comes off is so pollutive. It's a really big problem for just even permitting, right? So, but there's not really good numbers to address from that. We just take it down to zero. But the cost of it, the cost of it hasn't been well defined, but it's pretty much a rate limiting step for even permitting. And then the other big component, which is important to remember, is where you get the materials. So for the cathode, you have the lithium. It depends on the chemistry, but you can have like LFP or NMC, lithium iron phosphate, LFP. NMC is nickel, manganese, cobalt, and then of course the lithium. So where you source those materials makes a big difference in the carbon footprint as well. So where you source those materials, how you process those materials, and that's one of the reasons why having more regionalized supply chains is super important when you're looking at the carbon life cycle piece of the puzzle. And it's also why Europe has built out a lot of their policies to look at the life cycle, the carbon life cycle of like the battery passport and those things, is because it is such an important component when looking at the whole value chain of the battery.
Hmm, interesting. So now I think I don't know if I missed this. I know you talked about if Tesla had used the process to manufacture the batteries for their Cybertruck, they would have saved about $1 billion. So I want to ask one question: Do you does Sylvatex do the manufacturing of the cathode, or do you license this process out to manufacturers? How does this work?
Mm. I love the question, and also right now our stage we're pretty small volume, so we're moving towards a tonnage type of volume.
Hmm.
Um, which is still for the materials that we're making is it's like a size of a car volume of production, but you like the volumes that's needed for industry is going to be astronomical. So the volumes that are going to be right now, the US produces almost zero metric tons, and we need to
Whoa.
produce, I think it's something like 900 metric tons in the next few years to meet the demand. So I mean, that's significant volume, right? And each plant usually is about 50 metric tons at most. So if you imagine that's like 20 plants that need to be built real quick.
Wow.
Um, so I think I missed a little bit of the question that you're asking.
Yeah. Yeah. So yes, I think if you license the process or you do the manufacturing of the
Okay. So
yeah.
long story short, I mean, we're doing advanced manufacturing. So just as a company, our goal is to de-risk the scale up piece of it and then make it build repeat. So we're using,
Oh,
if you imagine, we're using like off the shelf equipment that is readily available. And so we want to make the materials, prove out the materials, go through the qualification process with said vendors, and then we're going to scale up the process. We're likely going to do a blended approach of our own immediate, like own manufacturing with joint partnerships, with development partnerships. But we'll also do, I'm sure, a licensing model because every single supply chain in the world is looking at ways to speed up, make the stuff more effective. And there's no way that we could build up capacity in India and Australia, within the same
yeah.
time period. So we're definitely going to be looking at a hybrid growth process, but as that really gets unlocked as soon as we minimize any technical risk.
Hmm. Amazing. So now, looking at the manufacturers who use these cathodes, how are they responding to this new approach of cathode manufacturing?
The generally they are responding well. I mean, if you go to any major supplier and you say, hey, we can make cathode material um, cheaper and more, using more regionalized inputs, more domestic, and it has a lower carbon footprint. They say that's great, and so I think that there's no question that there's substantial market interest. The challenge we have is how to get to scale in the most effective way possible, right? So and also how to build the business model so we can scale past early commercialization extremely, in an extremely large way.
Hmm. Okay.
So I think that that's, and the other thing we ask ourselves too, which is I think an interesting question, is we have, um, if our goal is ultimately to unlock lower cost batteries, we want to be closer to the end market. right? We don't want to have the value that we bring to be captured just in the material side of the market. We want to go end to the end consumer as much as possible. Um, so it's going to be interesting to see how that plays out.
Okay, so
Does
when
that
you
make
talk,
sense?
yeah,
Yeah.
yeah. Sometimes when you talk about going closer to the end market, I'm not really clear on that because I know the consumers won't buy cathodes. So what does that?
Yeah, so that means like working with a direct OEM. So if like you're working with a electric vehicle
Mhm.
OEM and they have the target to reduce their cost of their vehicles by 15%
Yeah,
to open up a broader market. Um, and that's gonna give access to low cost electric vehicles for a broader population, right? So if you want all those things to be true, and we're part of that solution, so we unlock a much lower cost of the battery, which unlocks, for like, it can change depending on the vehicle. It can change the price of the vehicle from anywhere from like 7% to 15-16%, so a pretty good chunk of the cost. And it like we would want to work more with the end customer and want them to have the value savings versus us just collecting it all or working downstream more, if that makes sense, because it will go more towards the end customer. um so exactly how you do that just means you work more with the partners that are further, like, closer to the customer, further upstream. Um, and then you just have to have a more robust, vertically integrated supply chain. So it's just a lot of collaboration, a lot of communication, and a lot of partnership.
yeah,
If to make that happen, right? Um, and you're going to see over time, things will start to get cheaper as you start building out these regionalized supply chains, and they're not there's more arbitrage on all the feedstocks and things like that. So just like any big commodity, that will start to happen more substantially.
okay. So now, I think we mentioned earlier, I think before the interview, I mentioned that the battery in my solar system, which I'm using right now, was the biggest single cost for the entire system. And you mentioned earlier too that the batteries in EVs are probably the biggest cost too for EVs. So adopting this, when this process is adopted widely, how would you say it would impact the cost of solar of electric vehicles?
Yeah, I mean, the going back to your example, I'm not exactly sure, but it would impact it, like, it'd be the direct reduction impact to the battery pack, right? So in the battery packs in vehicles, the battery pack is about 45% of the cost, somewhere between, depends on the vehicle,
Hmm.
but somewhere usually between 35 to 50% of the cost of the battery, so around 45. In energy storage types of applications, the battery is the whole thing. And then you have the solar panels, if you're doing it with solar installed, those things, you have the solar panels and those components, but those are relatively small, to your point.
Yeah.
So when you're reducing the cost of the battery of the cathode material, it has a direct reduction to the end pack. What I don't know, and I know that even though we're going to see that savings, I mean, it's a game changer in reducing costs. But who captures that benefit is going to be the other piece of the coin, right? So
Yeah.
that's going to, there's going to be the short term who captures it, and then there's probably the longer term who captures it, and that changes over time.
Okay. So now, I think looking forward, looking into the technology, manufacturing batteries and co. Where do you see EV battery technology going towards in the nearest future? I think with your process now, you can see the cathodes will cost less and co. So I think generally, where do you see it going?
I mean, you're going to see three major trends. One is you're going to start seeing regionalized supply chains very dramatically. So Every region's going to have more of a supply chain from feedstocks with either trade partners and, looking at all the raw materials, and then production of all the components of the battery, and then production of the battery pack just within a region. So we're probably going to have, you know, 3 to 6 regions built out in the globally. You're going to see with that, you're going to see advancements in manufacturing techniques, because there's really been a lot of innovation in the battery cell design and chemistries to get it down to where the cost is today. But to actually unlock low enough cost or lower cost, production, you're going to have innovation in the batteries, like in the manufacturing side of things. So not so much on making the battery packs, but making the components, which, of course, my thesis is cathode material is the most important component there, because it's the
Yeah.
largest cost. But you're also seeing advancements in manufacturing, like dry electrode production and things like that Tesla bought up a company a while back, and there's a lot more kind of manufacturers moving in that direction, because it does lower the cost and it should make it easier over time. It's hard to implement new technologies, of course. So, but that's, advancements in manufacturing is going to be the second. And then, of course, you're going to see a lot of change on sort of the feedstock and inputs. So it's going to take a while for recycled materials to come fully online, right? To like create this full feedback cycle where we don't have to mine and refine. But until then, you're like, we're going to see each region find and unveil sources of materials to collectively support that region's economic wealth and well-being. And it will also reduce carbon intensity of the supply chains as well. So, and it helps to minimize supply chain risks, right? Which all those things are like the major issues
Yeah.
that the industry has as it's growing and scaling. So I would say those are the three big things: regionalized supply chain, advancements in manufacturing techniques across the supply chain, and then you're going to see regionalized feedstocks really being unlocking its
Amazing.
value.
All right, so I think let's leave that and come back to you. So, what's leading a company in the green tech space? What's the most important lesson you've learned?
Oh man, swing for the fences. Like, I think the most important lesson I've learned is, like, no one else is doing stuff, like you have to do it. you know
Yeah.
I used to think, I had this concept before that they were doing this or they are going to figure it out. And I think as I've gotten older in my career, in my advanced life, I've recognized more and more that who's the they that are doing these things, right? There's so I think that's one really big lesson is you got to do it. You got to do it, and you got to play a big game. You got to be making the systems be built that are going to be future proof, that are designed to sustain and be better and higher performing in the future as they are today as well. Right? So, um yeah, play a big game. I'd say my one immediate big life. So many lessons though. Yeah.
Okay, so now for other people who, like you said, no one else is doing it. So a lot of people might be looking at different things they can do in this green tech space, but maybe they're apprehensive, they're afraid, or maybe they feel someone else has
Mhm.
has handled that aspect already. So for a person like that, what advice would you give to them so at least they start making their own difference in this space?
Yeah, no, that's beautiful. I mean, it is so cool to align with folks that come with the same, like, that have developed the same thesis as you in
Hmm.
some area. So even if you say, "Oh, I'd really love to develop distributed, wind in like dispersed regions of Morocco," right? And
Yeah.
even if you're not the one person that's only thought about that, the more that you distill a little bit what you think would be really interesting and why, and then you find the people that are doing it, it is amazing when you unlock that power, right? So I guess like how I'd summarize my advice is really outline the things that you think are going to be game changing, and then just start doing research on who is doing it. And if there's a gap, then you have some decisions to make about what you want to do with your life and
Yeah.
career. But if there's, if there are people working in that space, then that is, that is an area that you should and could lean into of potentially aiding in some support.
Hmm. Amazing. Amazing. So I think I've really enjoyed this conversation. I've learned a lot from this conversation, and I'm sure listeners too would be glad to know that there's something like this for the EV space that'll bring down the cost of batteries because I know most times when I try to convince other people, especially for solar, to go solar like me, they always like, oh, the batteries are so expensive and everything. So I think something like this driving down the cost is something that will make it look much better and make
Mm-hmm.
everything EV, solar, everything go more mainstream in the future. So for listeners, for watchers who want to learn more about Sylvatex, learn more about your technique, learn more about you, follow you, or anything else, continue this conversation. What's the best way they can reach out?
Yeah, so definitely reach out. I mean, LinkedIn is probably the best social media, as my friends like to joke. I don't have any social media besides LinkedIn, which is sad but true. Um, so yeah, find me Virginia Klausmeier on LinkedIn or at sylvatex.com, sylvatex.com. You can send us a message on there as well. But yeah, would love to support anyone in growth in the space. It's really the next energy revolution is here, and there's a lot of opportunity on the table.
Okay, so for anyone listening, LinkedIn is you can find Virginia Klausmeier on LinkedIn or silvertext.com to continue this conversation. So thank you so much for coming on GreenTech Pulse today. Thank you. And for the listeners, till next time, bye for now.